Welcome to this week's Swarf and Chips, a far cry from the normal chip fest. And I know what you're thinking. Why oh why is Lindsay sitting on this workbench? Well, let me tell you, this week's show is all about sheet metal. You'll find tool cabinets just like this in almost every machine shop, most of which will be made using different processes, such as bending, folding, laser cutting, and welding. So, the guys recently spent 3 days in Germany at one of the sheet metal industry's largest shows, and that's exactly what we'll be discussing, Blech Expo. So welcome to this week's Swarf and Chips. So, coming up in the show this week, we'll be showing and discussing 4 machines from the show, all of which are brand new technology. The machines are from Amada, Prima Power, Salvagnini and LVD. These are the 4 biggest players in this market. Colin and Paul will also get 1 minute to talk about what they learned about water jet cutting. But to start, guys, little challenge for you, 10-second highlight from the show apart from the machines we're going to talk about. Go.
All that technology, fantastic, lays everything like that. Him getting excited about some glue. Simple as that.
Okay, what's the glue? Because I have seen the glue video.
I can't remember what it's called. It was a better version of super glue, but it could fix his curtain rails.
You should see it on the MTD CNC Global channel. It is fantastic.
It is absolutely amazing.
Anything, and you can't break it.
I'm going to pull those
apart. You've got 10 seconds each.
Yeah,
10 seconds
too long.
each.
The hybrid technology from FICEP was fantastic. The fact that there was a machine that does plate or plasma cutting as well as milling, drilling and all those other sort of machining operations, whereas before you'd have had to have done them on different machines. FICEP have a machine that's got dual technology.
Yeah, well, that was great. I like the hybrid machine, but the new Convex laser machine, fantastic fibre machine, special type of laser, which basically means you can have a lower kilowatt machine to achieve better results. Massive European exposure and slowly getting a good footprint in the UK too.
And I think it's important to say that all of these that we talk about today are on the MTD CNC Global channel. There's about 50 videos that we shot.
Yeah.
A lot of them from Colin, so there's probably about 30 that are actually worth watching.
All right then, thanks Jens for that before you have a punch up. Today's first feature is from Prima Power. Very interesting one, this one. Let's take a look.
Claudio, we're on the Prima Power stand and we've got the Combi Genius. I know it's had some new additions, hasn't it? So what's new?
Yeah, we are presenting here a new edition of the Combi Genius 1530. 1530 being the size, the maximum size of the sheet metal which we can process. The machine is equipped with a new head. The head allows us to use and run the machine without any protection around it, except the grids, of course. The reason being that the machine has been CE certified using a special new head which avoids the reflections from the cutting area to get all over the place. This is let's say the biggest innovation on this machine. Of course, the other innovation is the sorting unit, what we call the LSR. It's a unit that can load the raw sheet metal onto the machine and retrieve part by part in a sorting sequence from the machine. So the machine can be run unmanned for a long period of time, especially if it is connected to a warehouse.
So that's very impressive. If we focus on the laser for a moment, what's the advantage of it not having to be covered?
The fact is that most of the operators still today would like to see the machine running from outside. Of course, we have lots of cameras inside that gives you a picture of what's going on. But, you know, we are in a way old style and we prefer to see what's happening directly with our eyes.
So it's obviously more operator friendly, and with the new style of automation, it's going to make you more efficient as well, isn't it, Claudio?
Yeah, the idea would be that our customers can range from the very simple installation where you do the loading and unloading almost manually to the, let's say, more sophisticated customers that are working with full warehousing, ERP systems. By the ERP system, they give the instructions to the machine to run a certain number of sheet metal, certain thickness, retrieve the material from the warehouse, put it onto the machine, retrieve the parts one by one, pile them on a wooden, for instance, cassette, and then eventually retrieve the wooden cassette inside the warehouse or the parts directly outside.
Fascinating, very educational, and thank you for your time.
Thank you. It's been a pleasure.
So before we get a few thoughts from yourselves on Prima, don't forget there's more technology to follow throughout the show. Amada, LVD and Salvagnini, all happening later on. So guys, let's talk more about Prima Power. Just one question. Why do they need to see that, they've got videos everywhere so they can see the work happening, but you said we were a bit more old school. What's that about?
You had a great analogy, didn't you?
Well, I think it's like if you were in an automated vehicle, autonomous vehicle, and you couldn't see out the window, wouldn't be as reassuring as if you could, would it?
It's like driving your car anyway. You never clean it.
Possibly, yeah.
The same as a machinist, isn't it? If a milling machine's glass was black and you couldn't see it, they wouldn't feel as comfortable.
Just have comfort.
But it has got cameras and stuff on this as well, which sort of surprised me.
It's not the same though, is it?
No, I know, but why do you need the cameras if you can see it? Do you know what I mean?
Yeah, well, I guess if you're at control, you use the camera. If you're not at the control, maybe you look. Yeah. But obviously, the thing we're not talking about is the fact that traditionally lasers were enclosed with glass that you can't see through, like a welding mask, whereas this is CE marked, and you don't need the glass. So.
Yeah.
So the laser's all covered up with a sort of case around it. Shroud.
Yeah. Anything more on Prima Power?
But it's a fantastic company. This machine's genius. I know it's called a combi genius, but essentially the raw material goes in. It's stored as well. All raw material can be stored, go in and come out and palletized all without human intervention.
So this is just a laser machine, or they do the whole solution?
They do everything. Right. They do everything. Yeah, this is the combi machine, but they can bolt automation, and you could have it as a standalone machine, but I wouldn't necessarily see that nowadays. It would be with an automation system.
Okay. Next up, let's talk about Amada.
Axel, we're here on the Amada stand, and this is technology I haven't come across before. Can you tell me about it, please?
This is a complete new technology. It's what we call, it's the first laser of a next generation of a fiber laser. We have presented the first time last year on Euroblech, so it's the first time now in the south to show it to a bigger crowd of people.
Okay, what is new? Essentially, we're using less kilowatts for the same or better result.
This is exactly what we've been talking before. So there's a trend ongoing, everybody's looking for more power, but more power also causes some collateral damages on the machine, so that's not all. It's like we say in German, shooting with cannons or little birds. So we try to show here a more intelligent solution, and the basic thing is that we have a so-called LBC technology, means we can pendle with the laser beam in the cutting gap, and this allows us to increase the speed by 2 or 3 times compared to a same power level laser.
Yeah, I've seen around this show 15 kilowatt lasers, and there is an argument about that there's a lot of heat, isn't there? Makes the environment difficult to manage. There's a lot of thermal destabilization. This overcomes that, doesn't it?
You brought it to the point. This is exactly. So it's very difficult to handle this high power. Of course, at the first view, it's really you can cut faster. You have a very much shorter production time. But on the other hand, you have to do the cooling. You have to live with the shorter lifetime of the skid table. So, like I said before, that's not all. What we do here is really a more intelligent solution. Just a very simple example, if we cut 20 millimeter mild steel, stainless steel on this 4 kilowatt Ventis, we can cut it faster than a regular 8 kilowatt solid state laser. So this is bring it to the point, huh?
Yeah, so the advantages are obvious. Let's talk about the disadvantages. Is there anything you can't do on here than you could do on a traditional fibre machine? Things like maybe inferior surface finish maybe, or isn't there any?
No, it's the opposite. We're not only faster, we are cutting with a more smooth surface, we have less burr. So finally, this is the decisive point. If a customer buys this machine, he can operate like a regular laser machine. There's no difference. He don't have to do anything extra. The cutting database, the parameters are set by Amada, so he just can operate like an absolute conventional laser machine.
So it's fibre technology people are aware of, but it's better for the environment. You're using less energy. Arguably, the lifetime of the machine will be longer. Total ownership of the machine less as well, maybe?
Finally, yes. Actually, honestly, I couldn't find a disadvantage. So it's easy to operate. You have the better quality. Most cases, the faster cutting speeds, and you can utilize this machine for all kind of materials. We promote this more in the area of stainless steel and aluminium cutting, which was so far quite difficult for a solid state laser, because you always had a bad burr situation and a very bad roughness on the surface. So this is much better here. So at the moment, there are just advantages we are talking about.
Very impressive, Axel. Thank you for your time and have a great show.
I appreciate it. Thank you very much.
Wow, he kind of sold it to me. No disadvantages whatsoever. Now, my first thought is it's almost too good to be true. Is it really, really expensive in comparison?
I don't know the price is the honest answer. I know it's not a lot more if it is, but I don't know the price. But in terms, the clever bit is you've come down on the kilowatts. And basically, but you get like this is a 4 kilowatt, but it outperforms some 8 kilowatt machines. So the advantages of that, you've got more stability in the working area there, purely down to the heat dissipation. On top of that, you've got this oscillating laser, and that essentially pushes it. So you get the same performance, the same surface finish as you would with a much larger machine, but you prolong the life of the machine, the bed.
Yeah, he certainly sold it to me, I tell you.
I thought what was interesting about the Amada stand, not just this machine, but quite a common theme throughout Blech was the automation of some of their other machines. And there was one of their press brakes on there that was automated, which had robots, and in fact, similar to what we see with LVD.
It was changing the tooling, though, wasn't it?
And also changing the tool in the bit that you did as well. So the real focus on technology on there.
Another thing, a theme I think of this event as well was the power of the laser. They're looking to bring it down. I mean, at one place said, we've got, I think it was a 30 kilowatt laser, but the general theme was actually this laser, 4 kilowatt will do about 8, and there was another one.
So what's the benefit of bringing the power down?
Well, if you go high powered, excuse me, it damage the material, but the main thing is the bed, and obviously the more power, the more electric, it's more expensive to run. There's obviously more money, bad for the environment. So what they're doing, they're trying to come back on the power, but without losing any benefit of having the power.
Where it's in days gone by, it was all about, can we get 10 kilowatt, 12 kilowatt, 15 kilowatt, 30 kilowatt, that's coming back the other way.
That oscillating, I'd say it's almost like a LFE or maybe HFT in terms of its...
Yeah, it feels like almost like a peeling motion, maybe trochoidal milling or like LFE, whatever. It's where
very clever.
It's doing this instead of going straight through the material. It's like peeling, peeling motion, oscillating.
Okay.
Right. Okay. Clever. Thanks, gents. Up next, LVD.
Stephen, thanks for the invitation here onto the LVD stand. Now we're looking specifically at the dyno cell. Can you explain what's happening in here?
The dyno cell is a small electrical press brake with a robot in front. It is created for customers to say, I would like to bend small parts, difficult parts also manually, and take a second or a third shift with automation inside.
Okay, now one of the key points you make on your presentation there is your programming wizard. I look at this and think, how am I going to program it? It's going to take me a long time, but you're saying 10 minutes.
Correct. So we have created the software especially for this cell here. So we are able to calculate into the 10 minutes the bending solution for a complex 3D part. Also, we can calculate inside the same 10 minutes the complete trajectory from the robot, how to take, how to regrip, and everything done automatically, stacking the parts, dropping in box or stacking on pallets.
So the communication between the robot, the interface between the robot and the machine, very well handled by you here, by the sounds of it.
Yes, correct. So we have a special robot interface. It's not anymore like a hand signal, it's something complete special. I cannot explain for a moment, okay? Where you can see that the robot actually perfectly follow the machine in bending and actually everything calculated automatically offline.
And now what we're showing in here is 3 different parts. So are we suggesting that you could have a machine and a solution like this and have 3 different jobs running?
Yes, correct. So if the tools can fit on a machine, we can actually make different parts in different input stations here and drop them in boxes or put them in stacking on the pallets. This is no problem.
What are the risks? Are there any risks involved with what you're doing? Couldn't there be any collisions? What happens if it doesn't bend the part correctly? Does the robot stop? Does the machine stop?
Well, most of all, if the part can drop off of the gripper, there is a sensor inside. I see, okay, there is no part, he will not continue anymore. So this is actually foreseen. Even if the air pressure is going down, there will be some solutions. Also a solution, if he takes up 2 plates together, he will also stop. with 2 plates, he can also first go back to his input position and see again or try again. If it always fails, then of course the machine will stop. So there will be non-collisions possible with the robot to the machine.
So Paul, you looked at 2 machines at the time. Talk us through the other one that we haven't just seen and we'll go.
Okay, so the other one was an LVD fibre laser cutter, the fastest machine at the show. And when you see it move, it was like lightning. Genuinely,
the fastest machine?
Yeah, claimed by the guys at LVD that's the fastest machine at the show. Yeah, that was a great piece of technology. But this too, what I like about this solution is the fact that, you know, you go in machine shops and there's a press brake there and you've got a guy there, he's putting a piece in and he's turning it over and then he's putting, you know, and all of this is completely eradicated by this robot. Now, what isn't in evidence here, which they will be introducing in months to come, will be to change the tools as well, like we saw with...
That was my question. I was about to ask you a question. Huh?
So they'll change the tools as well. So if you can change the tools, you can turn the part over, finished parts in a box. Absolutely.
If you look at this and you think, with a human being, how could you possibly be competitive? Because these things aren't scarily priced. I know they look futuristic, but they're not a lot of money. So.
And the programming is
easy to program.
Easy to program as well. And that was probably a barrier to entry, which quickly they've overcome. So it's a good solution.
The key here is automation. You know, both industries, that's what's happening now. And you've made a really valid point. It almost was the future, but it's happening here and it's realistically happening as well.
First time for everything. Wow.
You're mean today. Right, so 1 to go from Salvagnini, and after that, earlier I did mention, but Paul and Colin, you've got 1 minute to tell us about water jet cutting. So that will follow at the end of the show. So would you like to see a press brake on steroids? I hope so. Let's have a look from Salvagnini.
Seen absolutely loads of technology, press brakes, laser cutters, but here we've got, I'm going to call it a press brake on steroids. What actually is it?
Well, this machine is what we call a panel bender. It's a name that has been invented from Salvagnini, as the machine has been invented and developed from Salvagnini. It's a technology for bending panels that reaches an outstanding level of productivity, repeatability, quality, flexibility, and safety for the machine operator.
So this component here, for example, you're turning it around numerous times, but it's taking essentially the datum once, and the controls and the caliper are keeping that all in place, so you're getting that accuracy.
Well, the accuracy issue is a very, very crucial one, because the part here is on the panel bender is bent only once at the very beginning, when it's much easier to center properly the part, and then once the part is clamped in the clamp, all the bends are subsequently made in a row without needing to recenter. This brings the level of repeatability of precision to a much higher level than normal bending on a press brake.
Okay, and then the components themselves, you're putting in obviously flat components, different components, but the tools, the machine will change those tools with the programs for you? It's all automated?
Well, this is necessary. The tools move automatically, because when you're bending the different sides of a panel, the sides may have a different length, and so the setup of the tool has to vary, and the setup varies automatically according to the machine program.
Okay. And with those machine programs, it's actually sensing different programs, different materials, different thicknesses, the different spring and things like that?
It does. By every program, the machine, while clamping, is measuring the exact thickness of the material, correcting in case possible mistakes in the range of the thickness of the material, and it measures the tensile strength while bending, so correcting variation from the nominal tensile strength in the bend.
Excellent. That's just a very quick overview of what I'm going to call a press brake on steroids.
So, Jens, are there many machines like this with this much intelligence out in the market, and do you see them?
No. We don't know, do we, really?
No, I think there's a few brands that offer a similar solution, isn't there, where the tools are removed automatically and there's a robot or there's some sort of device that does it instead of a human being. But to me, the thing I don't know, Colin, obviously you did this and it's a good video. Do you need volume? Can you do lower volumes? Does it lend itself to fast turnaround of different components?
You need volume, obviously, when you're investing in something that price, and you can fully automate it as well, so absolutely.
But I would answer that and say you don't necessarily need volume, because the automation allows you to change the tools,
complex.
as long as you've got a bank of tools.
Yeah, but when you're saying volume,
pre-programmed.
More than one.
Yeah, more than one.
Yeah. But I would say
if it's your large volume, you don't need to change the tools, do you?
No. And tools are universal as well.
You're saying about changing tools, though. This is about, this final component here, came all together. It was like a big letterbox, like you've got at the end of your drive. You know, it's one of these, and it's just
By
a
the
whole
gates.
jigsaw. Absolutely,
Yeah,
yeah. When you
yeah.
buzz yourself in, it's like that. So doing loads and loads of different components. That's why it's got all those different tools. But poetry, just watching all this, it really was.
It is
I
fascinating.
mean, it's very clever, isn't it? It's very clever.
Well, it's sensing that the thickness and the I don't know what the word is, bendability and things like that, and just bring it. Yeah, but use that. Google that actually if you want bendability.
No, don't.
No, probably don't
and
do
the
that.
bend quality,
Yeah.
and all, you look at a bend, but I mean, it is to precise angles,
Yep.
you know, and that's the key to
We
it.
talk about microns, but this is a slightly different industry,
Yeah.
but this is exactly
Bend-
what you're saying.
bend-ons.
People talk about metal bashing in the good old days when it was pretty,
Yeah.
knife and fork, wasn't
Yeah.
it? But this is
And-
flexible and
Or
precision.
chopsticks.
And I think, in answer to your question, I haven't seen. I know they're out there, but we see loads of press brakes actually with the guy still standing at them, loading them. Not to this advancement,
That's
which
advanced.
I'm sure in years to come we will.
Absolutely
Yeah,
amazing.
Definitely. Okay, so now it's time for the big one, even though you've
Paul.
just called bendability the big one. Oh, gosh. It's time for you to give us 1 minute on water jet cutting.
By no stretch of the imagination are we experts on water jet cutting, but we learned so much at the show. First of all, Paul, why would you use it? What does it do?
It's a very industrial style of cutting, really, compared to laser cutting. I've seen it in a few places around the UK, but really the differences with water jet cutting, the main difference is the types of materials that you can cut.
Right.
They're kind of endless, really, whether it be stone, glass, plastics, granite, wood, whatever you're looking to cut. If you're after a versatile cutting solution, then a water jet machine.
So fibre lasers, essentially metals. This is anything. Okay. What sort of, depth of cut?
Well, that depends on the size of the machine. So
Yep.
in this machine, for example, the bed is about 1 metre deep. So you could actually have up to 1 metre in size to cut through it. And of course, it would take quite a bit of time.
Yep.
But it is possible to do those sizes.
This is only a very quick sort of overview. How's it cutting?
Well, it's a combination of high pressure water with almost like a sand or a grit.
Okay, yep.
And the force of that actually creates then
Right.
the cut. But here
Perfect
you'll see
timing.
typical applications and typical heights of applications and the materials here. This could be, well, that's a piece of steel, and then as we go round, you'll see
Wood.
more metallic parts. But yeah, you've got woods, plastics, nylons.
What about the accuracy?
Well, the accuracy they'll claim is very good.
Yep.
Whether it is quite as good on metallics as a laser or
Okay.
a fibre cutter, but yeah,
And it is only a quick bit here. What about, is it cutting 2 axes, 3 axes, 5 axes?
well, again, you can have a knuckle style head, which CMS had at the show, which
Yep.
we saw, which enables you to do multi-axis cutting as
Yep.
well, so for weld preparation and things like that.
Brilliant.
In fact, as you'll see here,
Oh, yeah,
this is a head that's actually got a combination on it, so you can water jet at angles.
Perfect question, perfect timing, Paul. That's
Absolutely.
it. We are now experts, is that right?
I am not sure about you.
Okay.
Yeah, well done, gents. Well, there you have it. Thank you for watching this week's show. Next week, we're at Mazak's open house event for the whole show, and we'll be talking about our top 5 highlights, and they are all UK premieres. But as for now, don't forget to keep those lasers cutting, those folders bending, those notches nibbling, and those chocolates crunching. We'll see you next week.
Chocolate's crunchy.
Yeah.
Yeah.